Hi students, welcome to chemistry class. So we know that we are already discussing about the electrochemistry. So in that we are already completed in the last class what what is meaning of conductors, insulators, semiconductors and superconductors, and also we are completed that electrolytic conductors and metallic conductors, that all we are completed. In this session, today class, I would like to discuss to you some of the definitions with formulas. Okay, let's start with the first one is a resistance. So you are already using this word oftenly in physics. Let us come to the what is the definition of the resistance. A very small definition, very simple definition is it is opposition to the flow of current offered by electrolytic solution. Okay, so it's we know that if you take any one electrolytic solution, suppose this is a beaker, in this beaker we are taking some electrolytic solution. These are the electrolytic solution. Okay, so when current is flow through this electrolytic solution, but that electrolytic solution having some opposition of flowing electrons. Okay, this electrolytic solution is gives some opposition to flowing of electrons. Now that property is called as a resistance. Okay, generally the resistant units is ohm. Okay, keep your mind ohm. Okay, the symbol of the ohm is this one. Okay, but there is a SI unit. The SI unit is kg meter square divided by Simon cube ampere square. Here S is called as Simon. Simon. A is called as ampere. Ampere. Both are great scientists. Both are great scientists. Simon and ampere. Okay, this is a SI unit. This is a common unit. So let's go to the exact definition. Another definition is if you take any one electrolytic solution, this is one electrolytic solution. What previously I mentioned that any electrolytic solution, if you take in that dip two electrodes. This is a two electrodes I dipped here. Okay, and if you take this is the electrolytic solution is taken in a conductivity cell, means you imagine this is the electrolytic solution and this is the entire is called as conductivity cell. Okay, this is a conductivity cell and this is the electrolytic solution. Okay, this is the electrolytic solution. Okay, this is entire is called as we are taking into the conductivity cell. Then this in this solution resistance, what we have this solution resistance, this is a solution electrolytic solution resistance is directly proportional. Okay, so I mentioned here this is a electrolytic solution. No, this is a electrolytic solution. This electrolytic solution is taken in one electrolytic cell. These are the entire setup is called as electrolytic cell. Okay, then in that situation the resistance of that electrolytic solution is directly proportional to the distance of separation between the two parallel electrodes. Okay, means this electrolytic solution is separated by this electrolytic solution is separated by some distance is separated by some distance which are two parallel electrodes. Okay, so means the resistance of the solution is directly proportional to the distance of between the two electrodes, parallel electrodes of the cell, and also inversely proportional to the what? Area of cross section. Means this electrolytic solution having some area of cross section. Area. This is having some area. Okay, and this is the electrode length is some L. Means the resistance, this is a resistance, this is a resistance is directly proportional to the length and inversely proportional to the what? Area of cross section. Area of cross section. Then if you remove this proportionality, then we have to keep one of the word that is called as rho. What is that one? Rho. Rho. This is called as rho. Okay, and you know L by A. Where rho, this is a rho, is called as specific resistance, is also called as resistivity. Okay, na? And very important is how the rho can measure. The rho can measure in one of the instrument that is called as Wheatstone. So we are using Wheatstone bridge. Okay, so the Wheatstone bridge main use which are used to measure the okay resistivity of any electrolytic solution. Okay, suppose we have any one electrolytic solution like NaCl solution, KCl solution, like such type of solutions is there. To measuring the resistivity, we are using Wheatstone bridge. Okay. Next, conductance. What is meaning of conductance? So still we are discussing about the resistance. Now there is another term that is called as conductance. In olden format, conductance is represented by C, but nowadays conductance is represented by G. So let us go what is the definition of conductance. It is a reciprocal of the electrical resistance. Means if you do the reciprocal of resistance, you will get conductance. This is a general expression. G is equals to 1 by R. Very important is another definition for conductance is it is used to measure the ease with which the current flow through the conductors. Means suppose there is a one conductor here, one conductor. So how much easily the current is flow through that conductor, that can be measured by using conductance. Okay, so we know already in the previous definition only, resistivity is nothing but resistivity. Okay, sorry, resistance is nothing but 1 by rho into L. Sorry, rho into L by A. That is the definition of what resistance. Okay, the definition of resistance. Based on the D's formula, this R value we are substituting here. When that R value is substituting here, then it is become this conductance Z is become 1 by rho into 1 by L by A. Okay, so you know that this A will go up based on the simple mathematics. A will go up
When A will go up, then the Z value is become Z is equals to 1 by rho into A divided by L. A divided by L. So this is the 1 by rho into, this is x 1 by rho into A by L. And very important is 1 by rho. What is there that I can represent in the form of K. Now Z is equals to, now Z is equals to K into A by L. K into A by L. Okay. K into A by L. What is meaning of K here? K is nothing but what? Conductivity. Okay, is also called as specific conductance. Is also represented by, is also pronounced by kappa. K is nothing but what? Kappa. Okay, I hope you understand. Here in the place of R we are substituting the rho into L by A, nothing but what? 1 by rho into L by 1 by A by L by A. That A will go up, it is become A by L. 1 by rho place we are substituting the what? K. Okay, now G is equals to K into A by L. Very important is now K is equals to, okay, K is equals to G into L by A. L by A. So this is another formula. This is all our converted formula. So in the next slide I will clearly explain how to write systematic manner. Even in my notes also you will see that how that formulas are derived one by one. So finally here is a K. The K is indicate the what? K is equals to what? Z into L by A. These are the formula which is used to measure the K. It's not K, actually it is a kappa. It is a kappa. The kappa is nothing but what? Specific conductance or conductivity. And very important thing is here what are using here? L by A. L by A here. The L by A is nothing but what? Cell constant, which are represented by G star. Okay. And very important thing is the units of this cell constant, that is called as G star, is represented by centimeter inverse or meter inverse. Okay, are you understand here? Very important thing is L L by A. L by A is nothing but what? Cell constant, which is represented by G star. The cell constant units are centimeter inverse or meter inverse. Okay, and very important is the SI unit of K. The SI unit of K is equals to what? Siemens. Okay, Siemens. Okay, so is a very important Siemens. Another units of K is, that is ohm inverse and centimeter inverse, or ohm inverse, meter inverse. These are the another SI units of conductance or specific conductance. Okay, so these are the few concepts about the what? Conductance and specific conductance and cell constant. Once again we are going to discuss very detail about the each and every topic in this. So the first one is what is meaning of conductance? Conductance is nothing but what? It is a reciprocal of conductance is nothing but it is a reciprocal of resistance is called as conductance, and it is used to measure the ease of current flow through any conductance. Through any conductance it is used to measure the what? Ease of flow of current flow. Okay, and very important is what is the formulas about the what? Conductance. So already we mentioned that Z is equals to what? 1 by R. 1 by R. So in the place of R we are substituting the R formula. What is the R formula? R formula is so the R formula is rho into L by A. This is the R formula. So we are substituting that value in the place of R. That is nothing but R is become 1 by rho into 1 divided by L by A. This is things. Okay. Now 1 by rho place we are using the what? K. 1 by rho place we are using the what? K. Then it is become Z is equals to K into 1 divided by L divided by A. Okay, then Z is equals to kappa into A divided by L. Now kappa is equals to Z into L divided by A. Now this L divided by A is nothing but what? Cell constant. The cell constant units are centimeter and meter inverse. K is nothing but what? Conductivity. Okay, na? These units are Siemens. Instead of Siemens, we can also use ohm inverse, centimeter inverse, or ohm inverse, meter inverse. These are the units of K. Okay, na? So I hope you are understand very detailedly. Let us move to the next one. Specific resistance is nothing but what? Resistivity. So I already mentioned that R is directly proportional to L by A. Then if we remove this directly proportionality, we have to use the symbol is rho. Here rho is nothing but what? Rho is nothing but what? Resistivity. Now the rho is equals to R into A by L. How is this expression we are getting? You take the what A this side, then it's become R into A. Then you take the L this side, this divided by L. Okay na? Then okay na? Then is a very important thing is when the A value is 1 meter square, L value is 1 meter, or A value is 1 centimeter, L value is 1 meter. Suppose see the definition of resistivity, that is called as rho is equals to, it is equals to resistance, means if you take the rho is equals to R into A by L. R into A by L. This is the formula what we seen in the last slide. Here the length is equals to what? 1 centimeter, and area of cross section of that electrolytic solution is a what? 1 centimeter square. Then the rho is equals to what? R. Then it is equals to resistance when conductor unit length is 1 centimeter and area of cross section is 1 centimeter square is called as resistivity. Means the resistivity is equal to what? Resistance when area of cross section is equals to what? 1 centimeter square and length is 1 centimeter. Then resistivity is become to the what? Resistance. And very important units of this resistivity is ohm, centimeter, ohm, meter. Any two units you can use it. Okay, these are the resistivity, conductivity, conductance, resistance with the formulas. Okay, thank you so much. Next class we are discussing about the what? Different molar conductivity, equivalent conductivity, specific conductance. This all are we discuss in the what? Next class. Thank you so much. Stay tuned.